Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover how to evaluate trig functions using the unit circle. So using the unit circle really is kind of like your cheat sheet for evaluating trig functions at these known angles. And what we know is that if we have this unit circle, that the cosine of the angle is just the x-coordinate, and then the sine of the angle is simply the y-coordinate. So if I want to find the cosine of pi over 6, what I do is I locate pi over 6 on my unit circle, which is right here, and the cosine is just equal to the x-coordinate of this thing, being that first coordinate. So this is going to be equal to root 3 over 2. Similarly, if I want to find the sine of pi over 6, what I know is that the sine of pi over 6 is just the y-coordinate, so the y-coordinate being equal to a half. And this works for, all these angles on here. So if I ask what is the cosine of 5 pi over 3, what we know is just 5 pi over 3 is right here. The cosine is the x-coordinate. And if I want to find, say, the sine of that one, what is the sine of that 5 pi over 3? This is simply the y-coordinate. So again, 5 pi over 3, this is the y-coordinate. So this is going to be negative root 3 over 2. We can also do this for your other trig functions. What about, say, the tangent of an angle? So what about the tangent of, say, 5 pi over 6? Well, we know that the tangent of 5 pi over 6 is related to the sine of 5 pi over 6 over the cosine of 5 pi over 6. The sine being the y-coordinate, so here is our 5 pi over 6, the sine being the y-coordinate, which is a half. And the cosine being the x-coordinate, which is minus root 3 over 2. If I multiply by the reciprocal, those 2's will cancel. So what we're getting is going to get negative 1 over root 3. Now, some teachers want you to rationalize this, and the way we can do that is we just multiply top and bottom of this thing by that root 3. So this is equal to negative 1 over root 3 multiplied by this special case of 1. 1 times root 3 is going to be root 3, so this is negative root 3 in the numerator. And root 3 times root 3 is root 9, which is equal to 3. Now, sometimes we ask angles that you don't spot on the unit circle. We ask angles where we have to find its coterminal angle. So what is, say, the cosine of 14 pi over 3? Well, I'm trying to find 14 pi over 3, and I don't see this. But remember that it comes down to the fact that if we know its angle, for instance, the last one we had, say, pi over 6. If we knew the angle, if it was this angle here, then it was just going to be, the x-coordinate and the y-coordinate. So what I have to do is I have to find an angle that is coterminal to this, which means that it's going to, its terminal side is going to live on the same terminal side as 14 pi over 3. Because really, we always have a angle in standard position, so it's positive. Its initial side is on the positive x-axis, and its terminal side is going to live somewhere, on the circle. So what I can do is, since this is periodic of 2 pi, this is, the angle 0 or the angle 2 pi, what I can do is I can take our 14 pi over 3 and turn it into a coterminal angle. So you can take 14 pi over 3, and then I can subtract off, say, a multiple of 2 pi. As long as I subtract off a full revolution, we know that it's going to have the exact same terminal side. So then 14 pi over 3 minus 2 pi, I have to get common denominator. So this is going to be the cosine of 14 pi over 3 minus 6 pi over 3. Top and bottom by 3. So this is going to give us the cosine of 7 pi over 3. Now, 7 pi over 3 is still too big because 7 divided by 3 is still bigger than 2. This only works for angles between 0 and 2 pi. So what we know is, again, the cosine of an angle is equal to the cosine of its coterminal angle. So I can simply just do this again. minus 2 pi. So this is going to be equal to the cosine of 7 pi over 3 minus, 6 pi over 3, which is going to give us the cosine of just, 1 pi over 3. So let me kind of take you through the angles here. So 14 pi over 3 is actually this. It went around more than twice. Now, if I went around just, say, to 7 pi over 3, what that means is I went around 1, like from here to here, so that would be 7 pi over 3. And then I can subtract off another full revolution, which is going to give us pi over 3. So, these angles, this 14 pi over 3 is coterminal to 7 pi over 3, which is also coterminal to pi over 3. They're all going to land right here. And since the cosine is nothing more than the x-coordinate of its terminal side, then this is going to equal a half. This works for all other trig functions as well. What if I ask for the secant of, say, of 3 pi? Well, what we know is the secant of 3 pi is 1 over the cosine of 3 pi. And again, I don't see 3 pi on here, so what I'm going to do is I'm going to find its coterminal angle, which means I'm going to subtract off 2 pi until I spot it. So this is going to be equal to 1 over the cosine of, 3 pi minus 2 pi. I know the angles are not equal, but their trig functions are, because remember, when it comes down to finding their evaluation, they're nothing more than the coordinates of their terminal angle, or their terminal side. So that's why I know that these are coterminal, therefore they'll have the same cosine values. So this is going to be equal to 1 over the cosine of just pi. Now pi is right here, the cosine of pi being the x-coordinate, so this is going to be equal to 1 over negative 1, which is going to be equal to negative 1. So if you like the content, please subscribe.